Okay, so I'm going to show you how to solve this problem using numerical differentiation. We have seen forward divided difference, centered divided difference, and backward divided difference. But probably if you are still confused on how to use these three methods for a certain set of data, so this video is definitely for you, okay? So we have here a set of data, time given in minute, which is 0, 10, 20, 30, 45, 60, and 75. Well, the volume is given in barrels, all right? These are the values. So the question is, calculate the flow rate of each time using the high accuracy numerical method formulas. So this one is the high accuracy Newton divided difference formulas. So we have here 1, 2, 3, 4, 5, 6, 7. So the question asks for each flow rate, each time. So you need to do differentiation for t equals to 0, t equals to 10, t equals to 20, and so on and so forth. So what you have to do is you need to recall back there are three methods that you can use. So this is the forward divided difference, and this is the centered, and for this one is the backward. So if you look at this formula here, you notice that the forward divided difference, it uses the forward data, meaning it uses the I plus 2, I plus 1, and the xi. And for the centered, it uses the before and after, which is the I minus 1 and I plus 1. For the backward, it uses the backward data, which is the I minus 2, I minus 1, and I here. So for instance, we go for the first data, which is t equals to 0. So we want to find the dv dt, which is the flow rate. So for t equals to 0, you notice that you only have the data after the t, after 0. You don't have the backward data. You don't have time equals to negative. You don't have. What is the method that you can use here? It's definitely forward, because you have the forward data when t equals to 0, or you have all the data after t. So here you cannot use centered because you don't have the backward data, and you cannot use backward. You don't have the data before 0. So all left is forward divided difference. So for dv dt, when t equals to 0, you use this one, the forward, use forward divided difference. So let's try to solve this, and this goes equals to, so negative number, negative here, don't forget the symbol, negative, and then xi plus 2. It means the value of the fx. So you know, if you don't want to get this confused, you can assume this as x and this is fx. All right, so the value of fx when x equals to I plus 2. So this is your xi, this is your xi plus 1, and this is your xi plus 2, meaning this is our current interest, and this is the one data after that value, and this is the second data after that value. So you just plug into this equation. fxi plus 2 is this one, 0.77 plus 4, fxi plus 1, which is this one, 0.7, and then minus 3 fxi, here this one, 0.4, and then divided with 2. H is the step size. So step size between this data to this data, between this data to this data, it is 10. All right, the step size is 10. And try to solve this, you will get 0.0415. I forgot to mention one thing. In order for you to use these three formulas, you have to make sure that the space between the data are equispaced. The spacing is the same. You see that from this data, from 0 to 10, the spacing is 10, right? From 10 to 20, the spacing is also 10. 20 to 30, the spacing is 10. But from here to here, it's different. It's 15. But from here to here, it's 15. Okay? From here to here, it's 15. Okay, next is, let's look at when t equals to 10. So when t equals to 10, what is the dv dt? Here, for this number. So you can either use centered, you can use forward, but you cannot use backward because you don't have the second, the xi minus 2 data. You have xi minus 1. You don't have the xi minus 2. This is your xi now. We are at number t equals to 10, alright? But you can use centered because for centered you only need xi plus 1 and xi minus 1, which is this value and this value. So when you use centered, you will get your answer as, I'm not going to show here how to do that. This one, why not you try on your own? But the answer is 0.0185. How about the third data when t equals to 20? Which method do you think that you will use? If I were you, I will use centered. You see, you have the before and you have the after. But for this one, you cannot use forward because the step size are not the same. But you can use backward because you have the xi minus 1 and xi minus 2 data. But for this case, I will use centered. Alright, so this one is, if I use centered, I will get the value is 0.009. Okay, so I'm going to explain how about the rest of the other data. So for this t equals to 30, the differentiation, you are asked to use the high accuracy numerical method formulas. So out of these three methods, the centered method is the most accurate, and then only comes both forward and backward. But the most high accuracy formulas is what we call as the unequal formula. So for this t equals to 30, I don't have the formula here. You can refer the formula in my lecture note. For t equals to 30, you can use the unequal data. The question is actually asking for high accuracy. So this unequal formula and centered formula are the most accurate method. Then only comes the forward and backward. So this one, it is obviously unequal. This is 15h and this is 10, the step size. So here you use unequal. And how about this one? This one you can use centered. How about this one? This one also you can use centered because same step size. And how about the last one? The last one, obviously you can only use backward. Okay, so I will provide the answers to all the derivative. We have the answer for t equals to 0, t equals to 10. When t equals to 20, it's this one, 0.009. If you use unequal, when t equals to 30, you will get 0.011133. When t equals to 45, the answer would be 0.009667. When t equals to 60, the answer is 0.01. When t equals to 75, the answer would be 0.014. Okay? So try this. If you have any problem, you can ask me. Thank you.